Hi, I'm building a new project. This project is a satellite image analysis library. Yes, I do plan to open source it, but I figured why not progress through it publicly? So I can kind of remember how I built it and go from there. So, day zero, I had to figure out which data source I wanted to use. I landed on Google Earth Engine, essentially because it was free and it was enough to validate my idea. Now, if this were to become a public library as I intend, I would probably have to do a tutorial to initialize and authenticate an account via Google Cloud. So I separated the project into classes. And the reason I did that is because I wanted to easily interchange parts. So, for example, you have a satellite provider that is better than Google Earth, right? Google Earth is free and it's wonderful. However, maybe you want more recent and more frequent data, you would probably have to use someone else or input your own. The validation class basically checks every single input that you put in, saying, let's check the time limits, let's check the spatial bounds, let's check your quota limits so you don't use up your computing power. The metadata processor calculates the ground dimensions right now, which feeds into the validation process. And eventually it's going to also calculate the metadata such as the time, the date capture of the photo, and whatnot. I tried to do that today. It didn't work out because I went down a rabbit hole of trying to limit computing power to essentially give you as much bang for your buck. When at the end of the day, I took the easier way out because I tried to optimize before I finished anything. That was mistake number one. Get a finished product and then optimize it. Don't optimize from the start. I also built a cache which allows you to gather images, save them looking if you already looked for an image or if you already found an image like this, and that would essentially save you time and computing resources from running another API query. I have the Google Earth Engine authentication. When I was setting it up on day one, it was kind of scary. I mean, if I were to do this trusting a random guy on the internet, I would probably not do it. So here's the main.py, if you will. So as of right now, you you connect, then you download a patch, you go through a bunch of validators, checking if the time is not too long, if the long and lat are not too far apart, and then it checks how far away in meters it is. Then it checks if you already looked this up, essentially saying, wait a minute, you already have this stored locally, let me just go fetch that. Basically, this part is the Google Earth Engine request. And when I try to save computing time and computing power, I removed this and it was a headache because it got lost somewhere here. So it selects the first image, then the red, green, and blue spectrum. Then it gets the metadata. This is necessary for the time of the flight, which is necessary to kind of stamp it and say, hey, look, you have this. This is from this, which is not only useful for cache but also for analysis. Then you make the image request to the Google's API. So here's an example of what the pipeline would look like just for the API key. This is not including the later layers, which I'll develop, but you would give a project ID. Obviously, the provider is Google Earth Engine. You would connect to it. So you have two options. You have center, which would essentially drop a pin and then use a threshold to find the min and max for both long and lat, or you just have the regular bounding box. Either method works, but not both methods. So here's an example of what the API request would look like. Now, if I were to run it again, I would not see this, but I would hopefully see that it was cached. And this would save computing costs. So to show you how the cache looks like, I have this example which was calculated by the bounding box, and this example which we just saw, which was calculated by the center point. So that was it for day 1. I will return with day 2, which might not be day 2, but you won't know that. Stay tuned for day 2.